reading this consensus specs in details only about like say less than a month ago, right, and not full time. So this is more like an overview and not like probably like a deep dive into like line by line of the specs. But hopefully, I took some time to understand how the materials are structured, and it was quite all over the place. So hopefully this is a kind of like a quick introduction to, if you just started reading the specs, how you should read it and be able to understand like what are the different artifacts that are available for you to understand the consensus layer. So basically, for five things today. So I'll talk about like what are the Ethereum specs, what constitutes the Ethereum consensus, what are in each of the consensus releases so far, how to navigate the consensus specs, and what are in the spec test. So first thing first, Ethereum specs, right? This is a basic overview. I would say that there are mainly like four artifacts that we all should be aware of. Two on the consensus layer, and obviously two more for the execution layer. On the consensus layer part, there's consensus specs. The links is provided in here. And the second thing is the consensus specs tests. I'll explain more details later. And then on the execution layer is similarly structured, where you have the specs in one of the repos. Execution layer has a like more proper name to it, right? So it's basically Ethereum execution layer specifications, and I think a lot of the developers on the execution layer would call it EUs. So that's also something to be aware of on the EL layer. The EL layer also has spec tests. They call it EAST, I think, EEST. So that's also something to be aware of. But mostly for today, I'll be walking through mostly the consensus specs and touch a bit on the spec test as well. Yeah, so that's the specs artifacts. The second thing I want to talk about is what constitutes the Ethereum consensus. Right, so when we talk about the consensus layer, there are different components, different topics on that. Just to highlight a few, the Ethereum consensus consists of deposit contract. That's how the chain accepts or acknowledges the staking ETH that's coming to the consensus. There's the P2P networking, basically how the client instance communicates with each other. There's a serialization part, how data is compressed and communicate and get signed. Cryptography, basically how the client or validator authenticates or signed information. There's the consensus, basically validators, how do they reach an agreement. So that consists of the RANDAO, how the sync committee are selected, how the proposer is selected, and so on. There's also fork choice, basically, when there's network partitions or network delays, how do you reach a consensus on what's actually a valid block and what's not? And obviously, attesting and slashing are all on the consensus part. Also importantly, APIs, right? So the consensus layer, the consensus client doesn't work alone. There's like third party that can integrate or talk to the consensus client itself. So the APIs consist of the Beacon API, the Engine API, and this also includes the API that the execution layer also requires to talk to the consensus client itself. So you'll find all these topics in the specs that I'll be talking more after this. The third thing is what are in each of the releases, each release so far. And actually, it turns out that knowing what constitutes each release is actually very important, because this is not part of what you can easily see in the specs. So it will be really hard to navigate the specs if you don't know what goes in each release, right? So to walk through them quickly, Phase Zero, that happened in December 2020, 4 or 5 years ago. That's when the Beacon chain, the genesis of the Beacon chain, right? So that's the kind of like the foundation layer of the specs of how like the Beacon chain works. The fundamentals are in Phase Zero. The first fork that we had is called Altair in 2021. And basically in this fork, it includes introducing the sync committees. It started to increase the penalties. So one thing to be aware is that all the slashing penalties that can happen in the Beacon chain, it started off like being very low, because when the Beacon chain started off, we were afraid that there's going to be a lot of errors that didn't come from the validating itself. So the penalties, and since because we are using like actual mainnet ETH for the genesis, it's important that we reduce the penalties at the beginning so that we can hash out all the details, all the failure cases before increasing them, right? So Altair was the first fork and also the first time that the penalties got increased. Not to the full penalties that we are expected yet, that comes later, but that's the first increase. The Altair fork is also important in terms that it is the first hard fork after Beacon Chain Genesis. So before we had the merge, right, a lot of the complexities are going to come during the merge. So Altair was also used as kind of like testing ground to make sure that all the consensus clients and all the people that are involving with running the Beacon chain actually experience the hard fork that's kind of like a minimal, that has like minimum changes before actually going to the merge. So that was a good testing ground. Then the third hard fork that we had is what was called Bellatrix in 2022. This was basically the merge itself, right? Merging the consensus layer with the execution layer and fully transition from proof of work to proof of stake for Ethereum. This was also the fork that all the penalties were put fully in place. So all the penalty values for slashing are in place during Bellatrix. The fourth fork is called Capella. This happened in April last year, mostly to do with staking withdrawals. Then in 2024 was EAP 4844, basically proto-shank charting mostly. And then there are two upcoming forks that are kind of semi-scheduled. Electra in early 2025, early this year. Main features that I picked out are max expected balance. So basically, you won't have validators that are staking 32 ETH, just 32 ETH anymore. Right? You are able to increase your validator balance to say 40, 50, 1,000 ETH inside a single validator. And there's also features to do with merging or consolidating validators. So you don't have to unstake your ETH. You can basically combine multiple validators, for example, 32 ETH validator and another 32 ETH validator together to form a 64 ETH validator without unstaking your ETH at all. There's also block throughput being planned. I don't remember the exact number, but the number of blobs that are included in each block is going to increase in Electra as well. And then there's for six, a soft limit 6, right, and max hard limit at 9. And then Fulu, I'm not so sure, maybe later in 2025, if I remember correctly, and that comes with PRDAS and Ethereum object format. Again, to reiterate, it's very important to know what goes in each release, because that's going to be important for all of us to navigate the consensus specs itself. Then here comes the big part, how to navigate the consensus specs. So again, two main repos to keep track of in order to follow along with the consensus specs. That's the consensus specs repo itself, and then there's consensus spec tests. The specs contain obviously the specs for each of the consensus release, and the spec test contains the test vectors for each of the consensus release, right? The vectors itself are actually generated from the specs, and the implementation of the specs goes inside the spec test repo. There are also some other related repos that might be of interest, but doesn't form like the core consensus mechanism. For example, the Beacon APIs, the Engine APIs, and Beacon metrics. These are all they all reside in their own repos. So if you're interested in those won't be in the consensus specs. You have to go through these repos to find out about them. Also, small note on EAPs versus specs. Although they are kind of like describing the same thing at a high level, they are very different in purpose, and you'll find different information in there. Right. So EAPs are earlier in the stage, mostly requirement specking. So it contains the motivation, the rationale, the security considerations, and high-level demo code of how the EAPs are supposed to work. Right. So it's basically communicating the whys of the proposed changes. And on the other hand, these specs, consensus specs, are more for the implementation stage, right? So it contains the what's and how's in order to implement the changes for each of the releases. So double-clicking into the consensus specs, this is the main repo of the consensus specifications. You'll see that this is where it starts to get hard to navigate, at least for me. You'll see like a lot of folders in there that constitute the consensus specs, but I think the important folders that you should be aware of are mainly only like 5 or 6 of them that I highlighted here. Right? The for choice, this contains some of the for choice functions. I'm not so sure why it's a separate directory here. It only contains the 2 functions in there for identifying the safe blocks. So if anyone knows information about this folder, would be much appreciated. The second important folder is the Solidity deposit contract. This is basically where the deposit contract, where you are depositing the ETH, the 32 ETH from the execution layer. This is where the contract lies, right? The reference contracts, at least. Then the third one is the specs. This is where the heavyweight specifications resides. It's divided into like different releases, which I'll talk more in detail in the next slides. And then some other features, for example, like the serialization is in the SSC folder. The specs for the optimistic syncs is in the sync folder. And then the tests are in the test folder. I'll talk a bit more about the tests because as I mentioned before, there's consensus spec tests, and we also have test folder inside the consensus specs itself. Those serve 2 very different purposes. So first thing first, the specs. So if you go into the consensus specs repo and then you double click into the specs itself, you'll see that they are divided into releases. For example, like phase 0, Altair, Bellatrix, right? So they are separated into releases. Another important thing to note is that these specs are actually extending the previous releases. So it's actually a diff, right? You can't expect that if you're looking for Electra, the upcoming release, going into Electra and you'll see the full beacon specs. That's not how it works. You'll only see the differences that are implemented from DNAP. So in order to actually see the full picture of the beacon chain, like consensus specs itself, you have to walk through from the latest release and walk back in time to actually gain understanding of the entirety of like how the consensus layer works. And so, and if you double click one time more, coming from the specs to the releases itself, then you'll see the specs files separated by topics, depending on what the release touches. These files will change. Sometimes you might see like the beacon chain. Obviously, for later releases, you won't see the deposit contract anymore. You might see P2P interfaces pop up in some of the releases, and on other releases, they might not pop up. Right, so this really depends on the changes that come in each of the release. And once you go into those files, then you actually see the actual specs written in Markdown format. Generally, it contains the description of how the consensus layer should behave. It contains the reference types, the parameters, and also the reference implementations written in Python. The good thing is that all these Python implementations are also written in peer functions. Basically, that means same arguments should produce the same outputs, and it contains no side effects, right? So this is a perfect kind of like reference code implementation, and it's also great because you can also easily write test cases for these without having to do any like very minimum amount of like setup and tear down for each of the tests. Another thing that is good to be aware of before actually going into the specs content is that when you go into, for example, like phase 1 specifications, you see like pages and pages of the specifications and a lot of headings in there, right? But to start off, I think it's easier to understand what a generic specs template consists of, right? And this is basically a template that you can find in the consensus specs itself. Namely, it contains the introduction, of course, describing what that document of the specification is about. The second thing you see would be the notation. I think this gets kind of dropped in the later releases. I don't see that anymore, but in the template it's still there, basically saying how to actually like understand the code snippets that happen that are inside the specs. You see the custom types. So these are all the types that are defined in each of the spec releases. For example, this is an example from the phase zero spec itself. So you can see that this is the specs that defines what is a slot, what's the type of a slot, the epoch, the root, the hash, and so on. The next thing you also see in most of the spec releases is the constants. So this is where the values that should never change gets defined. So you can see here, what's Genesis slot, what's the endingness what's the withdrawal prefixes, BLS, and also the ETH1 address withdrawal prefix. Another set of values that's important is called presets, and this basically contains the configuration values that may change at testing, but should generally be consistent across networks, either test nets that we have, or different ones that are interested in using this specs. Uh, Generally use the same presets. It's only the testing that actually might change these presets so that you can do unit testing or integration testing, or automated testing a lot faster by changing these presets. Um, and then there's the third kind of values called configurations. And this is basically the values that the specs writers are expecting that these values might change for different networks, including test networks as well. For example, the genesis time, the fork version, the delay, the number of seconds per slot, the seconds per slot, and so on. Right? These are expected that it could change depending on the network that's running this specifications. A few more things inside the template itself is something called containers. I would say like this is basically composite data types. For example, like it defines what a fork type is. So a fork should contain the previous version, should contain the current version, and should also contain the epoch of the latest fork. Um, Another clear example is, for example, validator container. So a validator should consist of its public key. It should know the withdrawal credentials of the validator. It should know the effective balance. It should know the if it's exit, it should know the exit epoch and also know the withdrawable epoch. So this is kind of like a composite data type that is defined within a consensus client. And the last thing that is defined in the specs template is the helper functions, right? So these are kind of like not really like it's the function that you use to create the other more substantial consensus like functions itself, but they are, for example, like here you can see that they are like math, which yeah, so these are like the helper functions. So having known the templates of the consensus specs, I want to kind of like give a bit more details on what the actual content looked like. Right? So I'm gonna get out of this window and I'll show the screen instead. So keeping in mind that these are the releases so far of the consensus specs, another convenient thing about the specs is that there's also online specs viewer embedded in the consensus spec itself. So avoid like if you want to avoid having to go into like GitHub and then click folder by folder, there is this like online specs viewer that you can conveniently look up in your browser, and then it's conveniently linked so that you can actually go through all the specs without having to jump back and forth between the folders and the files inside GitHub or inside your directory itself. Right, and just to confirm that this specs viewer actually represents what inside the consensus spec itself. So I can also show you that if you go to the consensus specs repo here, you go to the specs folder and to the release itself, for example, phase zero here and beacon chain. you would see the content of the specs, for example, introduction, notion, constants, presets, configurations, containers, and so on, right? And if you look at this online viewer itself, you can see that it's separated by the releases as you expect in the Git repository itself. And you can see here that if you go inside a release, you see this is basically the same as the beaconchain.md file. And you can see the content here that it's exactly the same as what you would see in the Markdown specs in the repo, right? So introduction, notion, custom type, constants, containers, and so on. Right? And this is where the meat of the consensus specs happen, right? So what's important is that you need to know what are the big changes happening. For example, like the phase zero is basically the genesis, right? So you see most of the information that's the fundamental um, um, like stuff that's needed to run the consensus layer. For example, like I mentioned, you have the custom types that defines the slot, the epoch, the community index, the validator index, and so on. You have the constants, for example, like the maximum value for UN64, the max square root of UN64, what's the genesis slot, what's the genesis epoch, and so on. You can see the withdrawal of prefix in there. You can see the domain types in here. You can see the prefixes, for example, like the max committee per slot. And as I mentioned before, it goes like it's different for different testing environments. So there's possibility that for different test network or different test setups, you might want to change these presets for your convenience. These are all the presets. And then you have the configuration. For example, in phase zero, you have the minimum genesis time, you have the active validator count expected, the fourth version, the genesis delay. This is where the seconds per slot is also defined, second per each one block, and so on. You also see the containers, basically the data types, the composite data types that are required to run the phase zero of the consensus layer, the fork data, the validator, attestation data, and so on. Yeah. And some important stuff, for example, beacon blocks is defined here. So you see what a beacon block body consists of. It consists of the random review, ETH1 data, the graffiti, the slashings that happened, the attestations, deposits, voluntary exits, and so on. Right? And this is basically what defines what a beacon block body should be. You also can find here the beacon state. Right? So what consists of the beacon state is also in here, and so on, and so on. Some other definitions that are in the phase zero, for example, the deposit contract. This is so basically information about the deposit contract. You also have the beacon chain fork choices. So basically here you can see how the validator selects what consists of a block. If I remember correctly, so basically you can see, for example, here, get proposer head, you can see that the conditions that, it's gonna figure out whether is the head late, whether epoch, so do not reorg if the chain is not finalizing, check if it's finalizing, check if the proposer is proposing on time, and so on and so on. And then it basically checks that if all conditions are met, then it would reorg the current head to the parent block. If not, it doesn't meet any of these conditions, then it's accepted. Right? So the block is accepted, and so on. So this contains all the beacon fork choices conditions in here. The phase zero also contains the networking. So this is where you expect how the definitions of how the validator clients are supposed to talk to each other. What are the endpoints? What are the messages? What are the topics that each of the client are supposed to talk to each other and supposed to be able to communicate to each other, right? So you can see the gossip sub here. You can see the topics, for example, you can see the gossip sub, for example, like message type, sending the signed beacon block, sending the attestation, sending the signed voluntarily exit, so on. And it also contains all the conditions in which the clients should accept or reject a message inside the specifications as well. Since because from the phase zero is basically the fundamental of the consensus layer, it's a lot of information here. So here on its validator, it also defines what keys are used by the validators, what the withdrawal credentials look like, how to submit a deposit, how to process a deposit. It also details the beacon chain responsibilities, for example, like proposing a block, how do you prepare for a block, what constitutes a slot, what's the proposer index, what's the parent root, how do you construct a beacon block body, how do you package them, right? So packaging the block, sign and submitting, and also attesting those blocks, um, aggregating those attestations, and in the end, slashing conditions. And the weak subjectivity guide, right? So all of these consist of the phase zero, which is like the hefty amount of the specs that's part of the CL. Then after this release, then you can see that for Altair, as I mentioned, this is kind of like a minimum changes to test the hard fork of the consensus layer itself. So you can see here that the changes are mostly sync committee, increasing penalties, and trying out the hard fork. So when you go into the details here, then you would see that most of the changes here would be about the sync committees itself or increasing the committees, increasing the penalties. For example, you can see here the domain type sync committee, selection proof. You can see this the modified containers. So you can see here it's also marked that it's new in Altair. The sync aggregate is new because it's to do with the sync committees. You can see that the beacon state itself store two more things, at least two more things. The sync committee and the next sync committees. You have a few new containers in there to do with the sync committees, and some accessors and some helpers to define how to retrieve the next sync committees and so on. So this is the Altair. The next release is the Bellatrix. So this one is the actual merge and increasing the penalties to the full intended amount. So if you go into the specs here, then you see that all the changes that are required to merge the execution layer into the consensus layer is in this Bellatrix specs. So for example, here you can see the container, the beacon block body gets execution payload added new in Bellatrix. You can see in the state that we are seeing the latest execution payload header being added to the state. And these are basically new containers. So these are entirely new because we are merging the execution layer in. So we are seeing execution payload consisting of the parent hash, fee recipient, the state root, the gas limit, the gas use, the block number, and so on, starting to being stored in the consensus layer itself. And the helper functions, for example, is the merge transition complete, is the execution enabled to help with the transition to proof of stake itself, and yeah, and so on. You also see the fork choices that start to, I think, add more information about the execution layer in here. The fork logic on this layer start to have execution information in there as well. Right? And you will see that in these the later releases basically would be repeat the same pattern, right? So In order to navigate this, you have to know the capella consists of, the main features are staking withdrawals. So you look in here in the specs here, and then you can see all the changes are required in order to enable the staking withdrawal. For example, new containers for withdrawing, the execution payload that all now start to contain the withdrawals, the withdrawal routes, and so on. Right, and this happens in DNAB. DNAB is also pretty much similar. DNAB is all about EAP 4844, so you would be expecting to see all the changes related to the blobs happening inside the specs here. Electra, similarly, max effective balances. So you would see stuff about like consolidating the validated balances, the withdrawal changes, and so on inside Electra. And in Fulu, that is mainly about PeerDAS. You'll see changes related to the data availability sampling and also the Ethereum object format inside. So for example, peer sampling here and the EOF format inside the Fulu specs itself here. So this is basically the consensus specs. The last thing that I want to share about is the consensus spec test. So this is basically still within the specs repo. One thing interesting to notice is that for all of the markdown formats, markdown specs that you see there, it's not only for human to read and understand, but it's also used to generate the specs, the full specs, and it's also the reference implementation of the code that you see in the specs itself. There's automated tooling that automatically generates the test vectors based on those reference implementations. And this is how it works. Right? So if you look into consensus specs setup.py, then you see that the automated generator here reads all the markdown file line by line, looking for Python code elements, then collects those code elements to generate the test vectors. You can also see that not only the code implementations, the reference code, even the types or the parameters are also collected to generate the test vectors as well, right? So this is kind of like kind of semi-guarantee that when the specs are generated, all the types of the reference codes get generated into tests and ensure that the tests are running. Another important thing is where those test vectors get generated. So this is a bit kind of like down the rabbit hole. If you go a few level folders down, you don't actually see the test itself. But if you go into consensus spec / test core PySpec E2 spec, I'm not so sure why it's that deep down, but if you go down there, then you can expect to see all the test cases categorized by the releases. So here you go into consensus, test, core, PySpec, E2 spec, test, Electra, then you will see the test cases for block processing and the consolidation request itself in here, and the full implementation of the specs reside in this deep down in this consensus spec test. One important thing to note is that these tests that reside inside the consensus specs repo, these are testing the specs itself to verify the consistency and provide feedback on modifications to the specs. They are not the reference implementation, or they are not the implementation for the clients, right? Most of the tests, however, can be run in generative mode to output the test vectors for client consumptions. But the test for client consumption itself actually resides inside the consensus spec test. So if you want to see the full details of how each of the clients are implementing the specs, you should go to the consensus spec test to see the full details. The test in here inside the consensus specs is only for the specs that you see in the markdown to verify that they are actually correct. So basically this, so this is the overall recap as I mentioned and shared about, what and where are the Ethereum specs, what constitute the consensus, what are in each of the release, how to navigate the consensus specs, and what are in the tests that are actually residing in the consensus spec repo itself. So next time that you want to look up and look up the reference for the consensus specs, one first thing first is be reminded that the specs are incremental. So you have to look at all the releases in order to see the full implementation of specs. Second thing is once you know that the specs are incremental, you might want to look into the meta EIPs so that you know what are included in each of the releases. Once you understand that well, what goes into each of the releases, then you can go into the specs repo itself to find out the actual specifications. If that's not enough, then you can also go into the test folder of the specs to find out all the test implementations, test scenarios in there. And if you're not satisfied, you want to look into more details, into more of the implementation test, then you go into the consensus spec test repository to see the full details. Moreover, if you're interested to learn more details, the specs only contains, like I mentioned, the what's and how's. If you want to understand more about the whys, then you should go back into the EAPs. And then there's also supplementary resources, which I listed out here, that also contains more of the whys of how the specs are written and why the specs are written that way. In the annotated specs, there's design rationale since Serenity. There's Phase Zero for Humans, I think, by Danny Ryan. And then there's also Upgrading Ethereum book by Ben as well, for you to learn more details about the consensus layer. And yeah, I think that's it for the consensus layer. Hopefully, not too deep, but hopefully, like if you're interested to learn more in details about the specs, this is how I started off and find useful. So I hope it's useful for others as well. And yeah, thank you for listening.
Thank you. Does anybody else have any questions? Awesome. I take that as a no. Is there anything else we'd like to discuss in the call?
I can give a quick update regarding the Winternitz paper. So Benedict Wagner, which is working at the EF on the paper will be published tonight. So
Okay.
yeah, by tomorrow or the next few days, it should be available online. And yeah, I am in touch with him. And yeah, once I know more, I will share it with the group, of course.
Awesome. Thank you. Looking forward to that.
Yeah, same.
Any questions?
Oh, and sorry, and thank you very much for the introduction. This was very, very helpful. Thank you.
So if there aren't any further questions for Anand, then probably we should consider what we cover in the next call. Any ideas on what?
I was thinking maybe we could do something of a study session for the Winternitz paper, no? I mean, if it's going to be out.
If it's out, yes, that does definitely make sense.
Yeah.
But we need to have plan B as well, because if that's not, then what do we consider? Any ideas? Should we dive into any one of the, or at least the latest consensus layer upgrade, and see how that transitions into changes in the code? Would that be helpful? Because it'll help us when we are building the Beam client as well, right? Or any ideas? I'm open to any ideas. Okay, probably have a think over, and then let's discuss this on Telegram if is there. So the first option is we do a I mean, a study session on the paper once it's released. Hopefully, Justin will also be there and chime in with his views. If not, we should work out something else. Yeah. All right. If that is all, then yeah, thanks very much, Anavat. Have a great session. And yeah, if you can, please share the link to this presentation as well for others in the Telegram group as well. Yeah. And thanks, everyone. Have a nice day. We'll speak again next week. Cheers.
Thank you.
Bye.
Bye.
See you guys.